This video, we're going to try to establish the way that we can use Hess's Law and compare it to a question where we've got just a communication concept. So here I've got a reaction where I've got 6 moles of sodium reacting with iron 3 oxide to produce sodium oxide and 2 moles of iron. Now I'm given the reaction enthalpy here. If I wanted this to be a Hess question where I was finding the enthalpy, they would have just not given me this value, and I'd use the formation enthalpies for these reactions. But that's not this question. So the kind of question we might have seen before would be something like, what is the molar enthalpy of reaction for sodium oxide? So this is the reaction that we're describing, and this is the enthalpy for the whole reaction. So this was kind of what we did when we were looking at communication. And if I wanted to know the reaction, molar enthalpy of reaction for sodium oxide here, I'd take that enthalpy, so negative 439.9 kilojoules, and then divide it by the number of moles of sodium oxide, which is 3 mole. That'd give me the molar enthalpy of sodium oxide in this reaction. So I'll plug that into my calculator, and we would end up with negative 146.6 kilojoule per mole. And so that's per 1 mole of this instead of per 3, right? And so that's one style of question. But another kind of question that could use the exact same information is, what is the molar enthalpy of formation of sodium oxide? Now, this is asking for molar enthalpy of formation, and this is not a formation reaction, right? So this isn't a formation reaction at all. So if it's asking for molar enthalpy of formation, and it's not a formation reaction, then I'm going to need to use my Hess's law so that I know that my reaction enthalpy is going to be equal to the sum of the number of moles times the formation enthalpy of the products minus the sum of the number of moles times the formation enthalpy of the reactants. And so I'm going to use that knowledge, and this is the reaction enthalpy. So my negative 439.9 kilojoules is going to be equal to 3 mole times the formation enthalpy of my sodium oxide. That's what I'm trying to find, plus 2 mole times the formation enthalpy of iron, which is an element, so it's 0 kilojoule per mole. And then I'm going to take that, and I'm going to subtract 6 mole of sodium times 0 kilojoule per mole, because sodium is again an element, plus 1 mole times the formation enthalpy of iron 3 oxide. And I can get that value from my data booklet. So the molar enthalpy of formation for iron 3 oxide is negative 824.2, and I had to get that from my data booklet. So plus negative 824.2 kilojoule per mole. This probably should have just moved all of this over so that it doesn't get too squishy. So I'll just do that. Oop. And so then, sorry, let me just fix this up because this is going to be a little hard to follow. So minus 1 mole times that negative 824.2 kilojoule per mole. So if I want to find this, I'm going to have to isolate for it. So I'm going to take my negative 439.9 kilojoules is going to be equal to, this first thing is 3 mole times the formation enthalpy of sodium oxide plus 0, because it's 2 times 0. So I'm just going to have 3 times the molar enthalpy minus 6 times 0 is 0 minus 1 mole times 824.2 kilojoule per mole is minus 824.2 kilojoules. Now I'm going to simplify it. I'm going to have my negative 439.9, and I'm sure you can do this much more smoothly than me, 3 times the formation enthalpy that we're looking for, plus, because negative, 824.2 kilojoules. And so 3 times the formation enthalpy is going to be equal to the negative 439.9 kilojoules minus 824.2 kilojoules, because I've taken this to the other side, right? And so my 3 mole times the formation enthalpy is going to be equal to negative 439.9 minus 824.2. So this is negative 1,264.1 kilojoule. And I'm going to divide that by my, so I'm just going to get rid of this now. I'm going to divide that by the mole. So the formation enthalpy of sodium oxide is going to be negative 1,264.1 kilojoule divided by 3 mole of sodium oxide. And I'm left with negative 421.4 kilojoule per mole. And that's a way you can calculate the formation enthalpy by knowing a reaction enthalpy. And that's actually what a lot of those formation enthalpies that we've got in our data booklet, that's how they sorted them out. They knew the reaction of an enthalpy, they knew the other formation enthalpies, and then they just rearranged to find it. So hopefully that makes sense to you.